Hello, I'm Stephen Englehardt. Today I'm going to talk to you about using OpenWPM to measure tracking on the web. I'll give you a demonstration of the platform and show you how you can use our web census data in your own research. As you may know, the web is very interconnected. When you visit a site, you don't just load resources from that site, but you load resources from all the third parties embedded on them. For example, if you visit CNN and the New York Times, you end up connecting to 84 different third parties. Any of the third parties that are shared between these sites will have the ability to track you. The proliferation of tracking that we've seen is really because of this lack of transparency. But measurement can help fix that, and I'll show you how both OpenWPM and our data can help make the web more transparent. If you're new to web tracking, there are really two main ways to do it. The first is using browser state. So when you visit a site, that site sets a cookie on your browser with an identifier in it, your browser stores it in its own database, and then on all subsequent page visits, the site can retrieve that identifier, and therefore know that you're the same user. Alternatively, a tracker can use fingerprinting. And here, instead of storing some identifier on your browser, they send a JavaScript file over when you first visit. That JavaScript file does things like read the fonts, read the screen resolution, and read the plugins, and then sends that back to itself. So it can do that on every page visit, and therefore know that you're the same user across multiple visits. And we built OpenWPM to measure both of these types of tracking. It's available open source on GitHub. You can check it out at the link at the bottom of this slide, but I'll briefly go over it in this talk so you have a better idea of what it does. So it provides both automation and instrumentation built in from the start, and it's built around Firefox. So we drive Firefox with Selenium, a browser automation tool. We have Firefox communicate through a proxy, so we have access to all the HTTP data that's going on. And then we also have access to an extension, which allows us to see things like JavaScript calls that are happening, cookies that are being set, and so on. And of course, we give the researcher access to each location within that platform, so they can very easily change things or customize things if necessary. So we wrap all of that up in something we call a browser instance, and our platform can run multiple browser instances at the same time to any number of instances. So this makes it very easy to scale up measurements and control them with our task manager. Everything saves to a central database, which makes it easy to analyze later on. And we use OpenWPM to run our own measurements. In particular, we use it for the Princeton Web Census, a monthly million-site crawl that visits the home pages of the top Alexa sites. We do things like collect the JavaScript calls we think might be used for fingerprinting, all the JavaScript files so we can verify if something is fingerprinting or not, as well as HTTP requests and responses, and any access to storage that might occur during a page visit. So this is really all of the things one might want if they want to run a web privacy study. And we think OpenWPM is suitable to tackle a bunch of different questions in web privacy. For example, we've used it to do a bunch of tracking measurement, but even so, anytime a new HTML5 API comes out, there's a new fingerprinting study ready to happen, and that could be run using our platform. I've listed a bunch of other things here that we find interesting and we're hoping people work on, but of course there are a bunch of other applications where our platform could be useful. And there are three main ways we see other researchers making use of OpenWPM in the Princeton Web Census. The first is to analyze our data, so this doesn't require you to play with the platform at all, but just to download the data off our site and look for new things in it. The second is to use OpenWPM to run your own measurements. So here you can actually just take the platform and run a new measurement without doing any additional coding. And third, we see people actually adding in new features and new instrumentation into the platform. And I'll walk through each of these and show how and where you can participate. We've released the web census data publicly on our site. I've linked to it here at the bottom of the slide. And in this data, we have monthly million site measurements that visit each home page separately and clear state between each page visit. We have a 100,000 site measurement that keeps state between it, so this is kind of like a normal user browsing. We have crawls that are helpful for identifying ID cookies and so on. And then we have a bunch of separate calls that target different ideas, like what does the web look like when cookie blocking is turned on, when Ghostry is installed, or for example, when HTTPS Everywhere is installed. And although we've only released 1 month of data right now, we do plan to continually release new data as we collect it in the future. So if you're interested in accessing any new data right now before that happens, just send us an email and we'll follow up with you. And in future work, we plan to provide easier access to the data where you don't need to go and download one of our databases. In particular, we want to put data up on, say, something like Google BigQuery or Amazon Web Services, where someone doesn't have to set up our same environment just to run queries on the data. And we're also working with the Data Transparency Lab to see if we can figure out ways to get this data in front of users in ways that are easier to understand or more accessible even for less technical users. And the second way we see OpenWPM being useful in your own measurements is to actually go and use it to measure new things without having to add any new code into it. And so, since we open sourced the platform in 2014, we've seen a bunch of different research studies go and use it. The ones I've highlighted here in blue are ones that I'm personally involved in, but the ones here I think are really the ones that are validating to us that the platform is both useful and easy to use. So since 2014, we've seen 4 studies come out that we had no involvement in, actually we had no knowledge of prior to them being released. And I think above anything else, this is what shows us that these authors were able to take the platform, make use of it, not have to contact us, and found it useful enough to avoid building their own. And I'll walk you quickly through a crawl script so you have an idea of what it takes to run a new crawl in OpenWPM. So the platform is written in Python, the interface is written in Python. There are really 4 main steps you need to do to run a crawl. So what I'm showing here is a demo script. It's available on the repository if you want to check it out. But the first thing you need to do is specify which sites to crawl. And you can just do that as a list or read in a CSV or so on. And the next you can specify the number of browsers you want to use. So scaling to any number of browsers is actually very easy to do. It's as simple as setting a new variable. Third, you need to configure the platform. So we have a bunch of default settings that make sense for many studies, but maybe you want to change something like enable or disable flash, or for example, enable or disable certain instrumentation. And next you need to define the commands you'd like to submit when you make the page visit. So in this example, we'll first get the site, sleep for 10 seconds, and then go and access the browser's cookies to see what changed during the site visit. Alternatively, you could have the browser visit the site, visit a couple links within the site, and then take a screenshot of it. So all of this is configurable very easily within the crawl script and in a pretty simple interface for the researcher. And we have documentation that makes it easy for researchers to figure out how to add new commands or change the platform in small ways. I've linked to one specific page here at the bottom of the slide, but there's a bunch of other information available. The third way we see other researchers being involved in OpenWPM and the Princeton Web Census is actually adding new features and instrumentation into the platform, and maybe even getting those new measurements run as part of the Princeton Web Census. And we have a wealth of ideas of what might be useful to add or what directions we'd like to see the platform go in the future. In addition to the things I listed at the beginning of the talk, we have a bunch of smaller one-off contributions that people can make listed on our GitHub tracker, and I want to take a moment to show you how easy it is to kind of change the platform to add some instrumentation for a specific technique. So every time a new HTML5 API is added into the browser, it would be helpful to be able to run a measurement study of it. To give you an idea of how much effort that would take, I want to walk you through 2 examples of our own measurement code for the things we currently have instrumentation for. So here is an example for both canvas fingerprinting and WebRTC local IP retrieval. And as you can see, our platform has a built-in instrument object function that allows you to monitor the getters and setters for any API you think might be used for fingerprinting. For Canvas, that requires just monitoring 2 interfaces, and for WebRTC, it's just 1. Thus, it's likely that any new technique would also require only a couple new lines of code to add in a new measurement. Now I'd like to highlight a few insights from our own studies that have used OpenWPM in the Princeton Web Census data. So all of these studies have been published and are available online. I'm only going to briefly go over the results, so I encourage you to check out the links at the bottom of the slides as I go through these if you want more information. First, we find that the measurement data we collect allows us to better understand the tracking ecosystem. So although there's a very long tail of trackers and there are a very large number of trackers involved, there's only a couple that span a large number of sites. As you can see here, just 6 organizations are present as third parties on more than 10% of the top 1 million sites. And we don't think this is necessarily a bad thing for web privacy. These third-party organizations tend to be under more scrutiny and have historically been more responsive to regulatory actions and measurement results. We've also used the platform to measure persistent tracking. In particular, the collection and monitoring of browser state allows us to do things like monitor cookie syncing, which is how 2 third parties can share identifiers with each other. In particular, we found that 45 of the top third parties are involved in cookie syncing, and actually if you took any 2 at random, there's an 88% chance that they share an identifier. So this shows us that cookie syncing is pretty rampant, and it's nice to be able to measure it and monitor it as we go forward. In addition, we could use this to measure cookie respawning, a technique some trackers use to bring cookies back into the browser after the user deleted them by storing them in multiple locations that the user may not clear when they clear their cookies. And in seeming response to lawsuits of the past, we find that this is largely unused by US-based third parties, although there are some popular third parties still using it globally. We've also used the platform to measure the adoption of new fingerprinting techniques. Although I won't have time to go into each technique here, I encourage you again to check out the link at the bottom of this slide. We're able to show that the Canvas, WebRTC, audio, and battery APIs are all being used to fingerprint users in the wild. I encourage you to check out the included link for more info on those results. And lastly, because we're using a real browser, we're able to test the effectiveness of privacy tools. So for example, we can install Ghostry, we can install AdBlock Plus, or we can set the browser to block third-party cookies, and then run a crawl with that. And to discuss the broad results, in our most recent paper we found that these tools are pretty effective at blocking stateful tracking, but do miss many fingerprinting scripts, showing that there is a need for measurement-based fingerprint detection, like the kind we do with OpenWPM. Thanks for listening to the talk. If you'd like to learn more about the platform or the measurement results I presented here, you can check out the paper linked at the top of this slide. I encourage you to go to our website and download our data and look at our analysis and play around with things. And if you'd like to collaborate, always feel free to reach out to us. So thanks again, hope to hear from you.